Now let's see how to test your application logic that uses Entity Framework, rather than writing tests directly against the DB context. Our publishing company has been growing by buying smaller publishing houses, so every once in a while they have a need to import a bunch of new authors all at once. It's time to create a reusable method to import these authors. So far with the console app, anytime I needed new logic, I just shoved it into the program file. And what I want for importing the authors is a method that's accessible to various parts of the application. So rather than adding it to the program file, I'll put it into its own class. Not only is this more realistic for building an application, but keeping it in its own class will also allow me to test the new method more easily. I've added a new class to the console project called DataLogic, and like the endpoints class we worked with in the ASP.NET Core module, the DataLogic class has a constructor that takes in an instance of pub_context and then sets it to a local _context variable that it will use for data access in this class's methods. And to keep my console app working without a lot of extra effort, I've also added a parameter list constructor inside this new class. And I have added my new import authors method. This method lets me import any number of authors by passing in a dictionary of string pairs. Then the method iterates through the dictionary items, creates a new author from each one, and then adds it to the authors DB set. When it's all done, it calls save changes. But instead of just calling save changes, I'm going to capture the result of save changes, which is the number of rows affected. And that result is the return value of the import authors method. So now I just want to make sure that this new import authors method is working. And rather than running and debugging the console app in order to do that, I can write a test that verifies the method. And here's where this type of test will differ from the in-memory test we already built. The first test was testing the pub context and its behaviors. But the focus of this test is to test my DataLogic class, which happens to use a pub context. So I still need to use SQLite's in-memory feature and verify that the import authors method returns the correct number of new authors. When building this method, I chose to encapsulate the effort of creating a new context that uses the SQLite provider with the memory option and then opens the connection and makes sure that the database is created. It's a lot of code to have in every method that would need an open connection. So now I can just call this method with a long but explicit name, set up SQLite memory context with open connection, and I could also create a method to create the other flavor, the one that has no connection, but I don't need that right now, so I'm just not going to bother. Now my test is really focused and readable. It creates that fancy context instance, and it also creates a dictionary of 3 string pairs. And again, I don't need to use real author names to prove the point here. Then I instantiate that DataLogic class, passing in my fancy context instance, and then my test asserts that the count of the author list, which is 3, matches whatever is returned by the import authors method in the DataLogic class, which should also be 3. Before I run my tests, I'm going to do something that may seem a little weird. I'm going to change the assertion to suggest that the result should equal 5. This is a common practice for testing, and you'll see the benefit when I run the test. Notice that the test failed, and we knew it would because I've only got 3 items. But the output explicitly says this assertion expected 5, but it only got the value 3. So I'm actually seeing that not only is insert authors working, but my test is written correctly as well. I know that the correct value came back. Now I'll go back and change the assertion to what it really should be testing, which is the count of the result. And I can do that with the confidence that when I run this test and it passes this time, that I know it's passing for the right reason. And I have double the confidence that my insert authors method is working. Because I separated the EF core calls into their own class, how does that affect my program class? That no longer needs to be aware of Entity Framework or of the pub context. It only needs to be able to instantiate a DataLogic object. I've created a new method in program called AddSomeAuthors, which creates a new list of 5 import author DTOs instantiates that data logic, and calls import authors, passing in the dictionary. Because I'm not providing a pre-configured pub context, I have no need for any reference to the context file or the publisher data namespace. So I can get rid of that code, and now my program class is even more focused and succinct. Additionally, because I'm no longer pre-configuring the context, running the console app will trigger the default configuration. I'll go ahead and run this, and we'll be stopping at a few breakpoints that I've put in. Here's the data logic parameterless constructor getting hit. There's one in pub context where the database gets configured, so you can see that running the console app will trigger our original configuration. And I put another breakpoint when save changes is about to be called, so we can look at debug view to see that it is indeed about to send all of those new authors into the database. And when all's said and done, there are the new rows in the pub database. So we can have our cake and eat it too. With this new architecture, where we've started applying separation of concerns, we can use tests that will use the in-memory database and run the application that will use our development database. And overall, our code is more readable, more maintainable, and more testable. What about testing in the ASP.NET Core app? First comes the question of what are we testing? Do you want to make sure that the app runs and the API works when calling the endpoints? And doing that in an automated way rather than using Swagger as we've been doing? Or do you just want to be sure that the calls to Entity Framework that are made in those endpoints are working? To achieve the second one of those goals, it would require another refactoring, moving the EF core effort out of the author endpoints methods. In a large application, you would definitely benefit from this kind of separation of concerns, and it would look something like what we just did with the data logic refactoring. You would have your EF core work in classes that are focused on that effort. For example, this getAuthorDTO by ID method, and then the map get logic in the API would just call that method rather than executing the query directly. In that case, you could very easily test the getAuthorDTO by ID method without even involving the API. But for the sake of this course, I am not going to do all of that refactoring. Instead, I'll show you how you can write automated tests that call the APIs and then assure that we're getting the data results we expect. I've added a new test project to the API solution with a reference to the Pub API project, and renamed the default tests class to API tests. And I've already added a number of test methods that I'll walk you through. And you will find these in the download, so you don't have to type them all up. First is a method that just ensures the API is working properly, and it doesn't involve EF Core at all. If there's a problem, I know it's not related to EF Core or a database or something like that. And that's why I left the original weather forecast logic in the API. The method just calls the weather forecast endpoint and makes sure that it gets the correct type of response data. So what's this code that I'm using to make this happen? Everything here is pretty standard fare for testing APIs, so you can find lots of resources to learn more about this. The first line allows the test to create an instance of the web application using ASP.NET's Web Application Factory and pointing it to our program class. Then it creates an HTTP client instance to work against. HTTP client gives us various methods for interacting with the API. Here, using the getStringAsync method, I'm just saying, hit the weather forecast endpoint and give me back the results as a string. And finally, in the assertion, I'm checking that the beginning of that string is as expected. I'll put a breakpoint there so you can just see the full response and understand why I'm using this simple logic. And there it is. Remember, the forecasts are very random, but I can always be confident that the beginning of the JSON has the word date in it. So this test passes, and I know that the API itself is set up correctly.